Hello there, guys. We're going over the last section in chapter 6, and it's what we're going to go through is we looked at examples where we first looked at like a probability distribution where they gave you. So we had a chart and they gave you the values. So they gave you the percents for 0, 1, 2, 3, 4, 5, and so on. So then we went to and said, okay, what if we don't have it given to us and we have a binomial? We just know the percent, okay, and we know the sample size, and we went through it. So then what happens then is if we start looking at it, so we worked with sample sizes of 5, 10, 15, 20, 25. Now what we're going to do is we say, well, what if our sample size isn't just that big? Well, what if it goes and gets bigger? So then what we start looking at is what we call the probability density function. Okay, what that means is we're going to start looking and say, what happens as we get more and more values as we get this curve that's going through. Now, they give you the formula for the curve is right here. One thing to note is you don't have to come up with any of this stuff. Right here, this right here is your standard deviation. So if you look at it, you have standard deviation, standard deviation. Then the other thing you're going to look at is you're going to look at mu and x. So really, all it comes down to is your standard deviation, and I should say mu right there, your standard deviation and your mean. Okay, so this curve is going to be based upon your standard deviation and your mean. If you look at it, the bigger the standard deviation is, that flatter that curve. So if I have a big standard deviation, we're going to flatten out that curve. A lot of variety in that. Okay, if we have a small, so if you look at here, okay, so we have a random sample has a mean of 35 and a standard deviation of 5. Okay, so our mean is 35. So if I just draw this curve like this, then it says, okay, so that's 1. Okay, mean of 35, standard deviation of it. Now, if you go to the next one, we have a mean of 30. Well, that's going to affect the peak of it. So instead of being up high, it's going to be a little lower, and a standard deviation of 2. Well, that's going to, so when I come through and I were to draw another one, I'd have like a peak. It's not as high as that one, but it's also not going to be as wide either because our standard deviation is smaller. So it's going to make it steeper of one as you go through it. So those are just important things to look at. What we're going to be doing is we're going to be coming up with a probability. So using the bell curve, we're going to come up with a probability. To do that, we use this right here. What this is, we're going to find a z-score. So the z-score is the number of standard deviations. Okay, a value is from the mean, and we do it by taking the x value, whatever value they give you. So if you want to think about it, it's the value minus your mean divided by your standard deviation. You need to write this down. This right here, we will use over and over and over. So what that means, just the x value, whatever value. What's the probability that you have 30, of a score of 30? Okay, so it's a value minus your mean divided by your standard deviation. So we're going to go to a couple things on here. Okay, so we're going to use this table here, this is a bell curve. It's in the back of your book. It should be printed out for you. We're going to use this. So we're going to use this right here. Okay, this table 3, and so this is for any standard deviation or any normal distribution. So we're going to go through the practice problems on this. Okay, so take out the worksheet on the practice problems, and we're going to go through it. So it says, okay, a couple things to point out. The average is 7. That's important. And our standard deviation is 1.5. That's all we're looking for. Anytime we use the normal probability distribution, we're looking for our average and our standard deviation. So we want to find the probability that a student can read less than 11.5 pages in an hour. Okay, so first thing we're going to do is we're going to take the value that they want. This is the value they want. So we go 11.5 minus our standard deviation, which is 7, minus our average, there you go, which is 7, divided by our standard deviation, which is 1.5. So 11.5 minus 7 that would be 4.5 divided by 1.5. So this is equal to 3. So now we're going to go. This is a positive value, so pay attention to that. So we're going to go on our chart to the positive value. So we come through here, so we want the positive values. We go to 3 on the chart, so 3.0. So we go down here, we got a z-score of 3. So right here, now we go 3.0. And you go right there. So the probability that the value was below 11 point, and so it's 99.87. So I'll go back here. And there we go. So it was 99.87. So this right here, so when we go ahead and look at the probability, it's 0.9987. Or if you were to write this out as a percent, we move it over twice, that'd be 99.87% that a student can read less than 11.5 pages an hour. Okay, so now we want to find the probability a student can read more than 6 pages an hour. So if it's less than, you're just going to look up that value. Once you get that value, you write it down. So now we want to go less than 6. So now it's our value minus our mean. Our mean was 7, divided by our standard deviation of 1.5. Order matters. So now we get 6 minus 7. That is negative 1, divided by 1.5. And so if I do that, that's going to be negative 0.66, and it's going to be 7 repeating. We're going to just round this to the 10th place. So it's negative 0.67. So it's a negative value. So now we got to go look up that value on our curve. So on our curve, we go through here. We want the negative values. So we want negative 0.67. So we go negative 0.6. Okay. So right here. So we're at negative 0.6. And now we want to go to 7. So if you look at it, this is 0. So this would be negative 0.0. 1, 2, 3, 4, 5, 6, 7. So this is negative 0.67 right there. So you can see the intersection where those two values meet. So that is 25.14 or 0.2514. Now, here's the important thing. Okay, the value that corresponds right here is 0.2514. We want to know the values that are more than it. So anytime this value right here tells me the probability that the value is less than it. So to find the probability that it's more than it, we would go ahead and we would subtract. Okay, so we're going to go 1 because it says minus 0.2514. And so once you do that, it's 0.7486 equals 0.7486. Again, we're going to round to the nearest percent. So I'm going to round here. So it'd be 75% as we look at. So there's a 75% chance that a student can read more than 6 pages. You go to the next one, okay? So if it's, I want to really emphasize, if it's less than, you just take the percent given to you. If it's more than, you're going to subtract 1 from the value they give you, from the value you find. Now, if it's between, we're going to have to do this twice now. So we're going to go 5. So the value they give us minus the mean divided by the standard deviation. So 5 minus 7, that's negative 2 divided by 1.5. So 2 divided by 1.5. I should say negative 2. So this is equal to negative 1.33, round to the 10th place. So that's one value. Then we have to do it again. Okay, so we found a value for 5. Now we got to find the z-score for 8. So 8 minus 7 divided by 1.5. 8 minus 7 is 1. 1 divided by 1.5 equals 0.6 repeating. So we're going to round to the 10th place, so 0.67. Okay, so now I'm going to look up both of these values, negative 1.33 and 0.67. So we go to the chart. Okay, so we want negative 1.33. So we go to the negative 1, and we're going to look up negative 1.33. So we have negative, so right here, so that's negative 1.3 is right there. Negative 1.31, negative 1.32, right here. 0.098. Okay, so 0.0918. 0.0918. Okay, so write that down. So 0.0918. And then we go to, so you write that down. Sorry, it's not where I want to go. So we go here and we write it down. So a z-score of negative 1.33. Okay, the percent that occurs is 0.0918. So now we look up 0.67. So we go to the positive side. We're going to look up 0.67. And as you look up 0.6 right here. So we're looking for the intersection. So if you think about it, we want to know 0.6 and then 7, where these two intersect. So where they intersect are right here. So we look that up, and that's 0.7486. Okay, 0.74. And we're going to go write that down. 0.7486. And we had that one before, sure. Okay, so this is, again, the decimal that goes with it, 0.7486. And now, since it asks what's a value that's between these two values, then we subtract 0.7486 minus 0.0918. And what we get is 0.65. So this is equal 0.6568. And so again, we would just round that. So this would be round that. So it would be 65.6. So it rounds up to 66%. So there's a 66% chance that the values are in between these two. So again, if they just say what's less than it, we take the value. If they say if it's more than it, it's 1 minus whatever value we have. If it's in between, find both those values and subtract it. So the professor wants to identify the bottom 25% of the class in terms of the number of pages they can read an hour. So it says find the number of pages per hour that defines the bottom 25% of the students. Okay, so we want to go through and find the bottom 25%. So again, if we look at it, our value, the z-score is equal to the x value minus, and if the mean, I'm just going to say mean, divided by our standard deviation. So right now, if you look at it, we don't know the z-score. We don't know the x value. That's what we're trying to find. We're trying to find that x value. We do know the mean. The mean is still 7, and our standard deviation is 1.5. So this is what we're trying to find. So we need to find the z-score that goes with the bottom 25%. So bottom, first of all, so we're going to go to the chart, and we're going to look for 25%. We want the bottom 25%, so we're going to look at our negative values. Positive values will give us the top. And now I'm looking for 25%. So like, if I look at these values, I'm looking here, out here. So this is like 20.3%. This would be like 20%. What we want to do is get as close to 25% as we can. So as I look, I'm getting, 22.93, 22. So I want to keep going, 23, 23, 24. So I'm getting closer. I want to find 25%. So there's 25.14. There's 25.83. So if I look at it, right in between here, is the closest I get to 25%. Between these two values, somewhere is 25%. So which one's closer? 0.2514 or 0.2483. So this one's closer. So what value is that? So if I look at it, the value that is negative 0.6. So it's negative 0.6. And then we go up, scroll up this column all the way up to where we see it. And it's negative 0.67. So negative 0.67 represents the bottom 25%. So I'm going to go write that in now. And so now we found the z-score that goes with the bottom 25%. And so I plug that in. So it's negative 0.67 is equal to x minus 7 over 1.5. And now you just solve this equation. So I got to get 1.5 out, so I multiply each side by 1.5. Okay, so those would cancel off. And so 1.5 times that by 0.67, and that is negative 1.005 equals x minus 7. So then I add 7 to it, and I get x is equal to 5.995. We could round that up and say 6. So a person, the 6 pages read would separate the bottom 25%. So if you read 26 pages or less, you would be in the bottom 25% of class. Okay, so now we'll go through something similar. Find the number of pages per hour that defines the upper 40% of students. So if I want the upper 40%, that means I want 60% or above. So this is the z-score I'm going to go look for. So I'm going to go look for it. So the upper 40 means I'm looking for, that cutoff line is at 60%. Okay, since it's above 50, I'm going to look at the positive values, and I'm looking for 60% as we go through it. So I want to find the top 60%. So again, this is like 51%, 55. So I want to get as close to 60% as I can. And if you look at it, it's right here. That's as close as I get to 60%. So that's 0.25. So 0.25, a z-score 0.025 is the cutoff to find the top 40%. So now I'm going to go plug that in. And then we go ahead and do our problems from there. So my z-score for the top 40% is 0.25 equals the x value, that's what I want to find, minus my standard deviation, or minus the mean is 7, divided by our standard deviation of 1.5. So first thing we go ahead and do is we multiply by 1.5, each side by 1.5. And so this is 0.375. So I'm not going to round till the end. And then I add 7. So that would be 7.375 equals x. So I could say if they read, we'll round to the 10th place, 7.4 pages. That would be the cutoff of the top 40%. So anyone who reads above 7.4 pages is in the top 40%. Okay, so we'd be 7.4 pages or more would represent the top 40%. Okay? So it's important to understand these are the 3 things that you're going to be, 4 things. Okay, find probability it's less than it, find the probability it's more than it, and find the value that's between it. When we go in between, it doesn't matter. Don't worry about inclusive or exclusive. For this one, when we go to the bell curve, the inclusive or exclusive doesn't matter. And then lastly, if they find the top 25% or find the bottom 10%, whatever it may be. If they say find the percent, the first thing you need to do is find the z-score that's associated with the percent they asked for, and then plug it into the equation, and then solve for the equation from there. So this is a huge thing. This is something that we're going to spend a big chunk of time now is going through using the bell curve from here on out.